Hello. In this video, we're going to prove that the opposite sides of a parallelogram are congruent. So I have a parallelogram here, and the only thing we know just from the definition of a parallelogram is that its opposite sides are parallel. So is that going to be enough for us to show that the opposite sides are congruent? So let's go ahead and do our proof, and I'll make my two columns, one for statements and one for reasons. And so our first statement is going to be simply that ABCD is a parallelogram. I spelled it wrong. There we go. And that was given to us in that very first sentence up there, so I'll write given. In number 2, we know that AB is parallel to CD and that AD is parallel to BC. Because we just talked about that's what a parallelogram is. It's the definition of a parallelogram. Now, we're going to do several proofs of this, and in almost all of these proofs, it requires us to draw in at least one diagonal. And so that was meant to be a straight line connecting AC. And I can, of course, draw in AC because any 2 points make a line. And what I want to do is now view this parallelogram as instead 2 separate triangles. And what I'm going to try to do is show that these triangles are congruent, because if the triangles are congruent, all the pieces, all the sides must be congruent. And so to say that these are, to start showing that these are congruent, I need 3 different pieces of this to be congruent. Since I have parallel lines, since we know that AD and BC are parallel, CD and AB are parallel, that allows me to talk about alternate interior angles. For instance, angle BCA is congruent to angle CAD. We also know the other ones here. These two that I just highlighted or tick marked here, that angle BAC is congruent to angle ACD. That's because alternate interior angles are congruent. All right. My fourth step is going to be the third piece of these triangles that'll be congruent to itself. And we know that they share this side AC, so I can say that AC is congruent to AC. Whenever something is congruent to itself, that's reflexive. Reflexive property. Finally, we can say that these triangles are congruent. So I can say, again, because it has 3 pieces congruent and they're in the correct places here, which we'll talk about in a second. So triangle ABC is congruent to triangle. In ABC, angle A went with C, angle B matches up with D, angle C goes with A. And so what's my reason for this? Well, we had a couple different, or I guess it was 4 different ways to prove that triangles were congruent. And I'm writing them down up here in the order in which we learned them. Again, side, side, side would be that we know that all 3 sides, or all 3 pairs of sides are congruent. Not the case. We only know 1 pair of sides. Side angle side would be 2 pairs of sides and the angle between them. Again, only 1 pair of sides. So those 2 are eliminated just based on not having enough sides. In angle side angle, we have 1 pair of sides congruent and 2 pairs of angles. Same with angle angle side. But where do the angles lie? Well, the side is between the 2 angles, so it must be angle side angle. And then finally, in number 6, we can say that AB is congruent to CD, and that AD is congruent to BC. And the reason I can say this is because we know that the triangles that contain them were congruent, so their matching or corresponding sides must be congruent. And this was our definition of congruent triangles. So just to recap, we started with parallelogram only. We knew nothing about the parallelogram other than its definition. And through that, we were able to prove the opposite sides are congruent. So this tells us that in any parallelogram, the opposite sides must be congruent. Okay, so we'll do more proofs in class tomorrow. For now, we are done.